Okay, I now know when the series converges, when a power series converges, and so I can talk about the sum of a power series is going to be a function of x. Okay, I'm just going to write plus dot dot dot. Because what the sum is depends on which number I plug in, which value of x I choose. And the domain of this function, whose domain is the set of all x for which the series converges. Because this function depends on the sum of the series, and so you need the series to converge. But the set of all x for which the series converges, that's just your interval of convergence. So your interval of convergence is the same thing as the domain of this function f of x. So I want to give you an example of what this function would be. So let's look back at our power series we started this whole section off with, x to the n. Last time we said that this was a geometric series. We said our r was x. And I also wrote at the beginning of class its interval of convergence was -1 to 1. Do you remember the formula for the sum of a geometric series? It's a fraction. Yeah, it's a over 1 minus r. This is the sum of a geometric series. A is the first term in our series, and so now I can write what the sum of this series is. What's the first term of this series? What was the first term in my list? 1. So it's 1 over 1 minus, and r was x. So this would be your function, 1 over 1 minus x. This is your function, and the domain of this, so this is our f of x. And the domain is the same thing of this function, is the same thing as our interval of convergence. It's -1 to 1.